Hello, students, and welcome to our Unit 3 review, our unit on relations and functions. We will review today and tomorrow. We'll have an assignment on Wednesday and Thursday, and Friday we will take our unit test. So let's get started. We'll begin with our Do Now, where we will thoughtfully answer a question about someone we admire. Our objective will be to review for our test on relations and functions. Our essential question will be our review topics. The topics for today are the domain and range of relations and functions. We'll take another look at those real-world graphs. And we'll look at equations as functions, and we'll look at function tables. So our assignment will be to watch the video and complete the assigned problems. And I want you to especially identify any areas where you are unsure. There will be some extra help opportunities for you. Our exit ticket asks us to complete the thought. A function contains exactly one blank value for every blank value. For homework, I want you to review any problems that you got incorrect, that you got wrong on this review today. Review them again tonight or this afternoon. And please come for extra help before we get to that unit test on Thursday and Friday. So let's remember, to get full participation credit, please turn on your camera during our opening discussion. It's just a common courtesy. And also, I want you to turn in photos of your assignments. Some of you are not turning your assignments, and let's try to get them on time. On Wednesday, you will have an interactive notebook assignment in teams that will count for attendance and for a grade. So remember, following directions in class is very important, especially when you are distance learning. So when you watch the videos and follow these directions carefully, you will know what is expected of you to do what you need to do to succeed in math class. Little fun fact for you today. If you had 23 people in a room, there's a 50% chance that 2 of them will have the same birthday. So think 23 people. It's about the size of a classroom or a large family gathering. So try that out. Ask people when their birthday is and see if you can find 2 people that have the same birthday. Our Do Now asks us to think of somebody we admire and consider what are they doing that has captured your admiration or earned your admiration of them. I know I always admire people who are focused and thoughtful, and they don't speak quickly. They think about what they need to say before they say it. I think that's a great characteristic. If you think about what it is about someone that they're doing, what are they doing that captures your and earns your admiration? If you do that, you'll discover what your own personal core values are. So think about that for a minute and write a quick sentence about that. We'll get to our exit ticket later, but for now, let's start our review. So here we are, first topic, relations and functions. So we are asked to identify the domain and the range of each relation. Remember, the domain is our x values. We write ordered pairs, x, comma, y. So that first value is the x value. So here's the domain. And we write them in order from least to greatest, and we use set notation. So the domain is -6, -2, 0, and 5. Put commas between each one of those. Now, for the range, we will look at the y values. Those are I've underlined in green. Again, use set notation. You don't always have to have the same number of x and y values. We'll talk more about that in a minute. So we do have a repeater. We have this 4 that repeats. So I only need to write that one time. So it will be -1 because I start with the least value, then the 3, then the 4. Again, finish up my set notation. Now, is this a function? Does each x value, let's write this down. Does each x value have an individual y value. Okay, so each x value can only result in one y value. A y value can show up as a result of two different x values, but each individual x value must have its own y value. So, here we have x value is -6 for a y value of 4. X value 5 for a y value of -1, x value of 0 for a y value of 3, and x value of -2 for a y value of 4. So each x value has its own y value. So that is a function. So now we have, instead of a set of ordered pairs like we had in number 1 and number 2, we're given a table with our x and our y values. Again, the domain, -4, -3, 0, and then the range, -5, 1, 2, and 8. Okay, look what's happening with -3. -3 can either give us a y value of 1 or a y value of 2. It's not an individual y value for each x value, so this is not a function. And number 3, let's actually let's name those ordered pairs. Let's identify them. So this, starting from the left, we have -1, 2, 3, 4, 5. So we have -5, 3, and here we have -3, -3. We have 0, 1. We have 2, -3. And then we have 1, 2, 3, 4, 5, 2. Okay, so the domain is -5 here, -3, 0, 2, and 5. And the range is -3, and here we have another -3, but each x value has its own y value, so we're okay. Moving up, so range, we're moving from starting at the bottom and going to the top, so we have a 1. We also have a 2. Oops, I meant to write 1 and I wrote 2, so let's fix that. We have a 1 and a 2, and then we have a 3. And that's the range. So what we have is an x value of -3 produces a -3, x value of -5 produces a 3. So we don't have any repeated x values. So this is a function. Okay, here we are given a graph in number 4. So let's itemize, let's list those ordered pairs. So we have -3, 1, 2, 3, 4, 5, -5. And we have here -2, -1. Here we have -2, 1, 2, 3, 4, 5, 6. We have +2, -3, and +4, 0. Look what's going on here. Let's change the color so you can see that. I've got an x value of -2 with a y value of either 1 or 6. Okay, it's a relation, it's not a function. I have to have an individual y value for each x value. So we still have a domain and range. The domain starts here, -3, -2, 2, and 4. The range starts here at -5. This is the y values. -3, -1, 0, and 6. And because we have a domain value with more than one, here it is, I'll circle it over here, with more than one y value, this is not a function. Okay, we've got a domain here, this is our x values, of 0, 4, or 9, and a range of 2, 3, 4, and 5. So let's first write that down. The domain is 0, 4, and 9, and the range is 2, 3, 4, and 5. But what's happening here? 9, a domain of 9 results in a range of either 4 or 5, so that is not a function. Now, number 6, we have a domain of -4, -1, 0, and 7. -4, -1, 0, and 7. And we have a range of -3, 8. But look what's happening here. Each x value has its own y value. It's okay if a y value is the result of a function of any of 2 different or 3 different or more x values. What we cannot have is this situation in number 5. But this is okay because each x value results in a very distinct y value. That y value can be repeated, but not the x value. So this is a function. And number 7, let's look at the domain and let's look at the range. So the domain, we're looking at the x-axis, okay, from left to right. And this function goes on to infinity, both negative infinity and positive infinity. So the domain is all real numbers. Or you can put that fancy R like that. The range, however, is, let's change our color. We're looking at the y values on the y-axis. And we have here 1, 2, 3, 4. This is the highest value on the y-axis. And that is a solid line. So we will say that y, because remember the domain is x, the range is y. So this range will go on to negative infinity on the y-axis, but it will go no higher than this point of 4. This point is, if we identify it, this is 0.24. So we say the range is y is less than or equal to 4. Now, is this a function? So let's see, is this going to pass the vertical line test? So wherever, anywhere on this function, I draw a vertical line, the vertical line will only cross one point on the function. So yes, this is a function. Now, number 8. What is the range, the domain? I'm sorry, let's start at the domain. So the domain starts here with an open circle on -1, -2, -3, -4. That's -5. So that is point -5, -1. So we're looking at the domain. So in terms of the right part of the x-axis, this does go toward infinity. So we can say that the domain, are all the values of x that are greater than this -5. And we have an open circle, which means we will use the greater than symbol, not greater than or equal to, just the greater than symbol. Now let's look at the range, the y values. So we've got a -1. Again, this graph is going to infinity on both the x and the y axis. So our range, again, greater than, because we have an open circle, and that is a -1. Now, do we pass the vertical line test? Yes, we do. So yes, this is a function. Now let's go on to number 9. The domain is from this point, which would be 0, 0, to 1, 2, 3, 4, 5, to 5, 0. And the way we represent this, remember, this is our x-axis. The horizontal axis is the x-axis. We would say 0, and we have solid lines, so we use less than or equal to x, and x is less than or equal to 5. Now, for the range, we have a point at -1, -2, -3, -4, up to the highest point, which is 3. So we will say -4 is less than or equal to, remember, we're talking about the range, the y values, and y is less than or equal to 3. Does this pass the vertical line test? It has to, I've had students say to me, oh, Mrs. Gold, it passes it right there. It just goes through one point. Sorry, guys, it has to pass the vertical line test at any point on the graph, and this does not. So this is not a function. Nice try. I'm glad you're thinking. So let's move on. And our topic now is real-world graphs. And we have the story of number 10 of Karina. Karina is riding a horse on a carousel. Which graph best represents her distance from the center of the ride in a single rotation? Let's pretend we're looking down on this carousel. We have maybe a pole in the center, and this is going to be our horse. And the horse is going around and around and around the carousel. And Karina is on the horse. So we're talking about the distance from the center of the ride. Basically, we're talking about the radius. And if she's going around and around on the carousel, then the radius will remain constant. So let's look at graph A, where we're starting out at 0, then we go up to some point, and then we come back down to 0 on the y-axis. But let's look at graph B, and let's also look at the labels, where we've got time labeled on the x-axis, where it usually is, distance from center on the y-axis on both graphs. But here, we've got a constant distance from the center. If we call this 0, and she starts out and she's always the same distance from the center. So that's definitely graph B. Read these very carefully, students. Now, on number 11, a cup of hot coffee cools down until it reaches room temperature. Okay, so it's hot, and then it's cool, and that coolness they're calling room temperature. Now, we're not putting it in the refrigerator. We're not making iced coffee here. Which graph represents the temperature of the coffee? So when it gets to this room temperature, I think we can assume it stays there. It stays at room temperature. And as it cooled off, is your coffee, you have your coffee or your hot chocolate, and it's really hot when you first get it, and then it's a little bit cooler, a little bit cooler, a little bit cooler until it gets to room temperature. It doesn't suddenly drop. If we look at our graphs, we have time on the x-axis and temperature on the y-axis. And in the first graph, we've got hot coffee that suddenly drops, and then it's the same temperature. On graph B, we've got hot coffee that gradually cools down and then stays at room temperature. So I think we can be pretty confident that graph B is the graph of the coffee cooling down. And then on number 12, it says Mitch went for a hike. He got halfway up the mountain and he realized he dropped his compass. So he turned around and walked back. He found the compass at the point where he started. Okay? So we're going to assume he starts at 0. He picks up the compass and he went back up to the top of the mountain, which graph best represents the total distance he hiked. So this would be, is 0 on the time, x-axis, and here we have 0 on the distance, y-axis, and we can imagine that as height, maybe in feet or yards or meters. So here in graph A, we just have a constant hiking up the mountain. And it doesn't talk about coming home, just says he hiked to the top of the mountain. So this is an incomplete graph of his total hiking day. So he goes up, and then he comes down, gets his compass, and then he goes up again. So I think if you look at graph B, here's the point where he realized he dropped his compass. And it does say that he went back to the point where he started the hike. So that would be the x-axis is where he started the hike. And then he climbed up the mountain past the point where he realized where his compass was missing. So that would be graph A. So let's go on. Now we're going to do a few more problems. Here we're talking about equations as functions, and we're graphing functions using tables. We're going to need a little extra paper for this one. So we have y equals well, let's read our directions first. Always read the directions first. Complete the table, then graph the function. So we have 2 things we need to do here. So if we complete the table, we're going to use y equals negative 2x plus 5. So this is number 13 we're working on. Y equals negative 2x plus 5. And they gave us a table with the values 0, 1, 3, and 5. So we have our x values, our y values, 0, 1, 3, and 5. Okay. I don't think we need to figure out any more than that. So what we're going to do is substitute these x values. We're going to make substitutions of these x values for x. So let's get started. So y equals negative 2. I'm just going to frame this out first. I'll change the color. So we're going to have 0, 1, 3, and 5. So as we evaluate these, especially the first one's pretty easy. Negative 2 times 0 is 0, plus 5 is 5. So that 5 will go right there in our table of values. If negative 2 times 1 plus 5 equals 3, negative 2 times 3 is negative 6 plus 5 equals negative 1. And negative 2 times 5 is negative 10 plus 5 equals negative 5. So let's go back to our paper and complete that table. We have 5, 3, negative 1, and negative 5. So let's go ahead and graph these. 0, 5 is right here. 1, 3, 3, negative 1, and 1, 2, 3, 4, 5, negative 5. And we'll try to connect those with a smooth line. And there we have it. We've completed the table and we've graphed the function. Remember, we had two things we were supposed to do here, and we've done both of those. So moving on to number 14, y equals 3/2 x minus 1. So let's use our scrap paper here. That's number 14. Y equals 3/2 x minus 1. Fractions should not be a big deal for you. Let's create our table. And we have our x values. Let's take a look at those again. Negative 2, 0, 2, and 4. So negative 2, 0, 2, and 4. And let's start evaluating. We're substituting for x. Parentheses are our friend. So negative 2, 0, 2, 4. Okay, so here, when x is negative 2, y equals negative 4. When x is 0, that's really easy, that one, y equals negative 1. When x is 2, y equals 2. And when x is 4, y equals 5. So let's insert those in our chart. And then we can go back and finish our problem. So we have negative 4, negative 1, 2, and 5. And we can go ahead and graph those. So negative 2, negative 4, 0, negative 1, 2, 2, and 4, 1, 2, 3, 4, 5. And let's carefully draw the line. That is the graph. And there you have it. Last two, I hope you try them on your own. I think we have enough room to work right on this paper. So number 15. Find the range of the function y equals 3/4 x plus 17 when the domain is negative 12, negative 4, and 8. So where do we start? With a table of values. So we've got y equals 3/4 x plus 17. So our x values are, domain is x values, negative 12, negative 4, and 8. So I'm going to write this 3 times, once for each domain value that I want to evaluate. And let's change our color. Okay, so we've got negative 12, negative 4, and 8. So 3/4 times negative 12 plus 17 equals 8. 3/4 times negative 1 plus 17 equals 14. And 3/4 times 8 plus 17, forgot the 1 there, equals 23. So we've got 8, 14, and 23. Now let's remember, what did they ask? They asked us to find the range. They didn't ask us to graph anything. So the range equals the set of all numbers such that we include 8, 14, and 23. All right, the last problem in today's review. Again, we're finding the range of the function y equals x squared minus negative x squared, don't forget the negative sign, minus 3x when the domain is negative 5, 0, and 2. So let's make a table of values. And our domain is negative 5, 0, and 2. Negative x squared minus 3 times x. We have to do 2 substitutions there. Let's neaten that up a little bit. Three times we'll write this, negative x squared minus 3x. And I want you to be really careful when you do this. Notice the negative is not part of the substitution. We're substituting only for the value of x. So we're substituting negative 5, and it goes in 2 places there. And we're substituting 0, and we're substituting 2. And when you evaluate these, you will find that in the first case, y will equal negative 10. In the second instance, it's obvious that y equals 0, because anything times 0 is 0. And in the third instance, we'll find that y equals, again, negative 10. So now we've got repeated range value. So when we write our answer, we only write that range value one time, starting with at least negative 10, 0. And that's how we write it. And that's a final answer. So the rest of the review, tomorrow we'll work on the function notation and some more complicated substitutions. Let's go back to our do now, or exit ticket, excuse me. So, complete this thought. A function contains exactly one x value, or let's be very thorough. One domain or x value for every range or y value. And that's the definition of a function. So many of you work very hard. I've been enjoying watching the grades go up, and I very much enjoyed your videos and your photographs, turning your work in. A lot of people have told me that installing Microsoft Teams on their phone has been very helpful and helped the work go really fast. Other people take pictures and then plop it in a Word document. So there's a couple of ways to get those assignments to me. But I'm really pleased with how you're really stepping up to the bat here, and you're working very hard in algebra. So enjoy this really delicious piece of birthday cake. And as always, with practice, you'll be great.